even more important. Okay? So I'm going to start talking about some of these things. So this is a site I show in courses when I teach, the Quartz Guide to Bad Data. Right? One of the best ways to get good data is to know what's bad data. And this is it's just a GitHub README that actually just lists a bunch of different things and links to other pages you can go to get more. You can Google and find it. I'll show you a little bit about what it does. One of the things they talk about is if you look at your data, and this is something people often forget to do, but you should look at your data and look at, just every so often, if you're scrolling through a long document, check it out, is see, are there special values? And this lists special values, and you may not know why a value is special. So why is 65,535 a special value? Anyone know? Yes?
2 to the 16th minus 1.
There we go, right? If we have a 2-byte word, 2 bytes, right, we have to worry about this, okay? Same thing if it's 32, right? Next one's 32, or even unsigned. If we're doing an unsigned, that's what the next 4 million is. Other things, special telephone numbers. Down here I have special zip codes. Right? Why might you have a special zip code appearing? You have to enter your personal data in, right? I don't want to know what zip code I'm living in, so I'm going to enter 12345. It's a valid number, right? Suddenly you get a huge spike in 12345, or 90210, or a phone number, 8675309. Famous old song, right? That people let it over and over again. That same thing. Now, a human, we know that. Oh yeah, that song, I remember that, it's stuck in my head, right? Computer won't know that, other than it appeared a lot of times. And why is this number overused, right? So the special values you should be aware of. Obviously, zeros used a lot in places as well. We also have to worry about dates. Dates and times are a huge issue. Okay, and I'll talk a little bit more about that. But that's something to always worry about. Are you seeing numbers that maybe you're seeing them more frequently than you should? Is there a reason you're seeing them? Is it because somebody just put a number in? Maybe you had underflow, maybe you had overflow. If you're getting data out of Excel, right? Different versions of Excel have different limitations in the maximum number of rows, maximum number of columns, the maximum number of data you could actually put in. If you're using a different tool, there may be other limitations. Right? So if you see, for instance, an Excel file come to you and it's 1 million rows, it should be a little suspicious. Okay? And that's, you might think of as magic numbers, things to be warning about. Another thing is, what if you get data out of PDFs? It sounds silly, but a lot of data is in PDFs. Sometimes that's to prevent people from being able to do stuff with it. Well, we had to publish our data, so we published it. It's in a PDF. You can read it, but you can't do a lot with it, right? So you might have to OCR it, maybe you're going to have to manually enter it, whatever. There could be issues there, right? So you need to know. That comes a little bit into data provenance, right? Which we'll talk about at the very end. Where does your data come from originally? What were all the things you did to it? What are the things you might want to keep track of so that if somebody else has to recreate it or get more of it or update it, what are all the steps they need to do? The worst thing is to have to come back a year or two later and try to understand what somebody else did, or even yourself, to data, because it wasn't written down very accurately. Other things we have to worry about. When you're using a computer to process data, they each have different data types. And if you move between languages, you should be worried about this. Maybe it won't be a problem, maybe everything was designed properly, maybe it wasn't. Right? And so we need to be aware of that. And just as an example, databases have ranges of things they can do. You need to be aware of it. Here I'm showing exact data types, but if we're thinking about floating point data types, we need to be worried about it. We can also, in programs, we can think, oh, it's no problem because Python can handle that data, but if somebody in the program is explicitly casting it as a certain type of data, right, now we only have 16 bytes to record our values, we're limited. We're back to 65,000 being a cap, right? So we have to worry about all of these things. On the other hand, there may be very good reasons for doing this, for memory, and so we want to keep track of it, right? And that's kind of the mantra of this sort of talk here is, you can do things to data, and it helps your end result, but make sure you're documenting what you're doing. And not just say, this is what I did, but this is why I did it. Right? Date times, oh man, we could talk about this for hours and hours and hours, right? I write 4417, what is that? But, right, I actually didn't even intend to do this. I made the slides up on April 4th. And I just realized, wait a minute, if I was in Europe giving this talk, they would look at it in a totally different way. Day, month, year. Here, people look month, day, year. So you want to avoid those ambiguities. And if you're in a year that's, 4, yeah, there's total confusion there, right? So you want to always be explicit, right? And use this. Something of writing it like this, not a good idea. Okay? Programming languages tend to have better support for date times nowadays. Use them. Okay? But we have to worry about that formatting issue. We have to know, are we using Julian days? Are we recording the number of seconds or days from some other time? And that's where it's always important to be documenting what you're doing. Timestamps, very important, knowing when things happen. When I talked down here at the research park, we did this. We started looking at data, and so it's like, what's all this crazy stuff in the data? It was just a CSV file on a government website. What the heck? Well, they used a different encoding. I don't know why. They didn't need to, but they did, right? So you see this sometimes called moji bake, because you get just strange characters appearing, right? And it's because it had a certain encoding and people weren't ready for it. So you might have to deal with that. You see that, again, a good reason to look at your data, you can see that. What happens when we have missing data? What do we do? This would be a great idea question. What should you do when you have missing data? A, delete the row. You laugh, but what's the number one thing people do? You drop, delete the row, right? Because, well, I don't know what to do, so I'll just get rid of it. I'll act like it didn't happen. Then you realize, you know what, I just got rid of 50% of my data. There might be some things there that I should know about, so I'm gonna impute or replace the data, right? Easy to do, right? One line in Python, boom, right? Fill NA. NA short for not available, right? The data's missing. But then you have to say, what value should I put in there? Should I put 0? Well, wait a minute, that was one of those special values I said to be wary of, right? Maybe 0 makes sense. Maybe it doesn't. You can easily fill with the mean value of the row, or the median, or some other statistic. And that might be a good thing to do, but you still might bias your statistics then for your full sample. So you have to be careful. A better approach is something like hierarchical modeling. Okay, where you can actually say the variable's unknown, I'm going to solve something bigger, but I'm going to impute that missing value, what it likely is. Okay, but that's more complex, so maybe that's overkill. It really is going to depend on what you're doing. Again, whatever you do, write down what you do and why you're doing it. So the big thing that I've sort of told you here is look at your data, right? So now I'm going to talk a little bit about what does that mean, looking at your data. We have here, I've read it into a pandas data frame. I call describe. It shows me I've replaced my missing values, so I don't have those anymore. And I can see, well, look, here's my mean value, the total number of count, how many there were, standard deviation, the minimum, the max, the percentiles. I can actually specify the percentiles. It's great, right? I can see my data. They look great. Okay, good. I can actually look at different data sets and compare them, right? And interestingly enough, here's 4 different data sets. They all have the same average, the same variance, the same correlation, the same linear regression. This shows the problem with just looking at data in tabular form. Our eyes aren't great at picking out those patterns or problems there, right? So you look at that and you're like, oh, okay, that's kind of weird. But if I just plot them, right? This is Anscombe's quartet, very well known. It shows you why you can't simply result on or refer to basic stats. Okay? The pictures you can completely see. Oh, yeah, they're all got issues, right? This is very different than that. But statistically, they were the same. So we want to look at them tabular-wise. We also want to look at them image-wise. And a great way to do that is pair plots. You just plot them up. You take a quick look. This is the iris data set. I have to show that like every time, right? And you can see, well, there's a nice linear relationship in these 2 variables. You can actually see the clusters pull out, right? You can see a lot of stuff here. Before we even apply any lasso regression, right, or neural networks or anything else, we can see, you know what, it looks like there might be something good here. And we can get some idea of that. The one question about the high-dimensional data, right? PCA, TNSE, these are all ways of reducing the dimensionality of your data set. This shows us that, look, our data aren't spread uniformly in every set of dimensions. There clearly is a lower dimensional representation, and that thus we should pursue that before we apply any machine learning. So it's very valuable skill to do. So the last thing I'm going to mention here is data provenance, and basically this is the least exciting thing about data science, right? Yet it's one of the more important things. Maybe the most important thing, other than the end result. Because it doesn't matter how good a job your little demo project is, if you can't A, repeat what you did, and B, show others exactly what you did. And that's fundamentally what data provenance is all about. Where did you get your data? Did you get it from, the Bureau of Labor and Standards government website and Weather Underground, and then this corporate Excel database and this corporate SQL database, and you pulled them all together? Well, you better keep track of all of that, right? And not only that, you better know when you pulled those data sets and what the query was and all of that. Then what did you do with it? Did you impute missing data? How did you do that imputation, right? And one of the things I like to say here is that through all of this process, what you're really doing is future-proofing for yourself. It's like you're writing an email to yourself in 6 months or a year. Hey, today I did this great stuff. You're going to forget you did this, so I'm going to remind you. You will thank me, because you won't have to redo it and spend a week or two redoing it and then feel like a fool because, wow, I did this once. Why? I tell students this all the time. I get in my research group, I'm like, write down what you do, write down what you do, write down what you do. They show me stuff, I go, did you write it down? Right. Where's the proof? Because if you don't have it written down, it didn't happen. You could have just pulled this image, you can pull this off the internet. I want to see, right? I want to see what you did. So that's always very important, right? If you don't have that written down, that provenance, all of that stuff, it'll be hard to reproduce what you did. It'll be hard to explain to people what you did. When you want to put it in production, they're going to want to see this. What are all the steps we have to do? What are the things we have to do to ensure this is going to keep working? So that's all I was going to say. My final thoughts. Hopefully, if you have any questions, let me know.
Thank you, Robert, for enlightening us on data. So I'm going to welcome up Ryan and Jason, Ryan Herr Jason Bowles from Country Financial. So I'll help them get set up here. So they'll be talking about hiring data scientists. So shifting from thinking about diving into data. So really talk just in general skill sets around data scientists. It's certainly an emerging field in the industry, so this is a very relevant topic. So I'll let you take over. So let's welcome them.
So as Matt said, today our talk is about how to get hired as a data scientist. And the reason why Jason and I are talking about this is because getting hired, it can be hard. Recently a blog post went viral, and it was called "Some Reflections on Being Turned Down for a Lot of Data Science Jobs." It's actually by the great data scientist, the same one that Professor showed the naive Bayes meme, named Tim Hopper. And here was Tim's conclusion. How do you get a data science job? I don't know. Some luck, some persistence, but he offers some advice anyway. And today, Jason and I will offer some advice as well, based on our experiences. So here's a little bit about me and my timeline. I'm kind of an unlikely data scientist. About 6 years ago, when I started working actually with a lot of U of I research projects, I was a business generalist, jack of all trades with State Farm at the time. And really at the time I started getting interested in data science. It was around the time of 2012 election, Nate Silver, a lot of exciting things happening there. And in my role, also at work, I was working with U of I students, talented folks like many of you, putting together like PowerPoints for here's an innovative idea that we should try. And a lot of them were use big data to ... And I started to think, okay, that's nice, but that's not really an idea. It's more like a placeholder for an idea, and I want to do it because really the value is being able to do it. So I said, but how am I going to get into this? I haven't. I'm a smart guy. I know I can learn this, but I haven't taken a math class since AP Calculus in high school. I have a undergrad in fine arts. How am I going to get into this space? And I thought, well, I actually started computer programming about 20 years earlier. I couldn't claim 20 years experience because it was off and on, more off than on, but I had those roots, and I thought, I'm going to get back to that. And Hadoop had started to be this emerging thing, at State Farm, but wasn't really taking off yet. I said, I can get plugged into that. Maybe I can't go straight to data science, but I can, take a step in that direction and get adjacent to it. So, did I wait until there was a Hadoop job posting? No, that would have been a big mistake, because for one thing, then I would have been competing with a bunch of other people. Instead, I created my own opportunity. I said, okay, who's the manager who is who's working on sort of like experimental proof of concept around Hadoop? And then I need to do some show and tell with a work sample to prove that I can do this job and to be proactive. And if I can get the opportunity before it becomes a posting, then I'm not competing with other people. And by the way, if you're a manager, posting a job and going through that HR process is a huge pain. So if I'm saving them from that, and they're saying, gosh, how am I going to find somebody who knows this new thing called Hadoop that nobody was talking about at State Farm in 2012? Wow, this person just really saved me a lot of effort. So I go home, I download the Hortonworks Sandbox virtual machine. I say, okay, I write up something to say I did word count, because for some unknown reason, that's what everybody does first with Hadoop. And I explain, here's why I could really help you grow this thing at State Farm. And Rick, he said, this is awesome. I'm going to find a way to get you over on the team. So I became a Hadoop developer. And I still focused on, okay, how can I work with data scientists? And still, nobody at State Farm at that time was officially called data scientist quite yet, but it was emerging as this thing. And it's not hard to predict where things are going to go, right? I mean, a big business like State Farm, the Wayne Gretzky quote about innovation, where you skate to where the puck is going to be. Well, if you skate to where the puck already is in the world outside the big business, then that's where the big business will catch up. So, I tried to find a mentor, and there was a guy named Jason Sanchez, who was one of the first data scientists at State Farm. But I didn't just say, okay, teach me, what do I need to know? Instead, but here's a couple general principles now. We generalize from a specific example. This could be my #1 advice to you. Do not just send your resume into a black hole. The only way that will work for you is if there is little competition, that you're either head and shoulders above other people, or else there just weren't many applicants. But otherwise, you need to be a warm applicant. And it's not that hard, but people don't do it. I mean, HBR, Harvard Business Review, recently they had an article about the best data scientists go out and talk to people. And that would be something, talk to the people in the companies that you want to work for, or the teams that you want to work for, and make sure that you're a warm applicant. Either a referral through somebody you know that works there, or if you don't know anybody, then no problem. Introduce yourself through LinkedIn or whatever. Find a way to get to know somebody who is on the team. And then some other advice here. This was some of Tim Hopper's advice. For the sake of time, we have a link at the end where you can read all these interesting articles. So I'm going to skip over this. So let's just skip all past this. But and I'll turn it over to Jason to talk about the next one.
Thanks, Ryan. So let me talk. I didn't put a slide here to kind of describe who I am, so I kind of I'll just wing that part. But it's kind of interesting. Around 2012, when Ryan was saying, "I'm done with business. I'm going to go back to kind of IT," I was the opposite. I was in IT from 2001 all the way up to 2011. About that time, I decided I'm fed up with IT because too often I was getting requirements that were substandard, wasn't meeting requirements. I wanted to get on the other side. I wanted, hey, maybe I can be better on the other side. And so I went back to school, got an MBA, sorry, and decided I wanted to go on the business side, but also while doing that, fell in love with operations, management, and statistics all over again. And at the same time, we had a Lean Six Sigma group at Country, and I thought, that's what I want to do. I've been working and messing with data my entire career. I want to use data now to solve problems. And so I started getting interested in that part of it, and right around that same time, the data science stuff started really popping up, and then Hadoop came along, and I thought, oh man, I should be back in IT, but I stuck with it and decided I'm going to stay with the data science track and try to set that up and use my software hacking skills for business good. And so I made a niche for myself as a business guy that didn't actually write code. And so that's how I kind of came to be as a data scientist. And so my history with data is really strong on the data wrangling side, so I'm really glad to hear that Professor Robert Brunner had talked about that, because I really feel strongly about it. And that's kind of one of the things that I want to talk to first, is that there's just more than modeling. And you know, I would love to be really, really good at all the different algorithms and all the neural networks and deep learning, but I'm not there yet. But I still spend over 80% of my time thinking about data, how to wrangle the data. But the key thing is really understanding, do you have enough data? Do you have enough features to form a hypothesis around your data? For example, we have a problem at Country where we have a model, we hire agents, we call them financial reps, as employees, and then they can hopefully convert to an independent rep after 5 years. Our failure rate in that program is like 80%. And so we wanted to see if we can predict who would fail before we even hired them. The problem was we didn't have a lot of good data about the personal characteristics of the person coming in the door, because they kept on changing the interview process, they kept on changing the data collection method. And so we thought, well, what data exists out there that can tell us a little bit about the person? Because we have this theory that it wasn't really all about the person, it may be the environment that they're hired into. So how many people were on staff, how many different employee reps, how much insurance was selling, other things like economic variables, what's the competition, so Bureau of Labor Statistics, how many people are employed in the insurance industry in that area, what's the unemployment rate in that area. So we built this data set to see, can we predict just on economic factors and the environment they're in, whether or not they would fail. And we actually proved that we could. And so the key skill that we used there was not really modeling, it was coming up with a way to frame the question so that we can actually solve something. And it turned out that we could do it, but the process of implementing that model was so long-term that the business said, we need something right now. So we changed the question. We said, now, well, instead, if we can't implement this model in the hiring process, maybe we can infect the hiring people. So we knew we had agency managers. They were hiring 4 people at a time, knowing that 3 of them would fail, and then turning over the failed book of business to this one that was remaining, and then have a success with that one person. It was like, can we identify those agency managers that are doing that, and then put a cap on them? So can we predict who would hire, how many people, and how many of those would fail, and then tell them that, hey, you can't hire more than 8 people this year to fill your 6 spots. And once you hit your 8, you're done. And so we were able to limit hiring, project out, so we used a more regression model inside of a linear programming model to optimize hiring, and we actually were able to implement within 2 weeks from the original question to the other, just by changing the way we were asking the question. So it's really key to understand the data and also understand what you can do with the data and maybe how to frame the question. So I learned a lot through that project of not just modeling, but more of how to frame the question in something that will actually impact the business right away. The other thing I wanted to point out was data wrangling. So, you know, Professor Brunner talked about 80%. It's cleaning and pruning. It's also about getting the data. And so we have a lot of data at Country. A lot of it's still in databases that you still have to make your connections. You have to write SQL. And we have a huge lack of people at Country that can write SQL on their own. They rely on platforms like Business Objects, Tableau to get their data, but sometimes it takes a little more creativity to get that data out. And so oftentimes we're writing our own SQL, and we're trying to convince people that that is a great skill to have, and that if you don't have that skill, you're paying for it somewhere along the line, either with somebody else besides your data scientist who's writing SQL, or a platform like Business Objects who's doing it for you. And the great thing is that Matt and I, we work together, Matt Hartman over there on my team, we both have this skill, and we don't have to wait around for someone to go get the data for us. We go get it ourselves. And we also, because of that skill, we also are able to get around data problems. Like, for example, when, with the retention project we're working on, we found that the cancel date for our policies was corrupt in about, I'd say about 30% of the time. And so what we did was we did an inner join against the table against the previous record to pull the cancel date from the previous record if the current record was corrupt, which was a skill that you can't really easily do in Business Objects or Tableau. And we had to get down to the nitty-gritty with SQL to solve that problem. So the point here is it's more than just about modeling. The other thing is there is so much out there. One of the people that I ran across as I was working on a retention project was Cameron Davidson Pilon, and kind of inspired me with his quote here about how he has a process, a set of tools that he uses to solve problems. He sets it up as a binomial problem, and then once he does that, he has a set of tools that he can go through. And he has this process, and you can see from this quote, of how he goes through and tries to solve his problem. And then at the very end, when he decides that, hey, I don't have the skills, or one of my existing tool kits don't actually work here, he gets to go out and learn a new tool. And that's how I've been approaching my problems is, hey, my first problem was more of a binary classification. Now I have that in my tool bag. Now the next one became more regression and then linear programming. Now I'm back to binary classification. So I have those things in my toolkit, and I have those things to go through. And so I would, if you were starting out, be an expert in one. I had a professor in college that talked about being an expert in the area. And the key thing about being an expert in one area is not just becoming an expert, the fact that you're an expert there, but it actually shows people that you have the skills to know how to become an expert. Because there's lots of becoming an expert in one area. Just like in IT, back in the day, I was an expert in our billing system. And so I had shown skills that was relevant, that, hey, I know how to dig into a problem and understand a concept or technology that no one's really understood before. And I think this is true not just for data science, but anything you're doing. If you're going to be focused on the business side, if you're going to be focused, you can think about how do you put together requirements. You can think about from development. You can be really good at testing. I know it's boring for most people. It is for me. But somebody really good and expert at testing is a very valuable person. So that's kind of the point for this slide here. And then the last one that has really benefited me in my career is having a mentor and being a mentor. The first thing, having a mentor for me, it's I was fortunate enough when I started my career in IT. I had this guy who was an amazing mentor to me, and now and I've just realized the value of that. Because number one, you don't know everything, and it shows humility to say, hey, I've reached out and I've asked for help. I know my actual limitations. I know that there's people smarter than me, and I don't have to know it all to actually to be successful. But I know how to ask for questions and ask for help. In our environment today, we have actuaries who are phenomenal math people, and I am not. And so when I remember having a conversation with one of our actuaries, and he was talking about a Poisson distribution, and I'm like asking him questions about this. I've never heard somebody call it a Poisson distribution, and I asked him about it, and he wrote the formula. I thought, oh wow, thanks. Can you draw it for me? Because I don't know what that means. And so, but I was, and at first I was a little worried about saying I don't know what that means, but I've actually learned a lot more because I've been open with him and said, can you explain this to me, because I'm not the math guy who you are. Marketing analysts, they are very skilled at there are certain problems in retention is a project I'm working on now. They have a lot of background there, so I have to lean on them a lot, ask them a lot of questions of where they've been, what they've learned. And then outside the company, we are fortunate enough to be close to Illinois State, and reached out to a professor there who's working, he's retired now, but he's also working for government institutions, and he's trying to predict whether or not people will be off, how long they'll be on unemployment. And so that's very valuable for me to get his insight on how to do retention in the country. Bloggers, there's a guy named Stephen Oates who wrote a blog that I felt was really great. So I reached out to him on LinkedIn, tried to connect with him. We passed back emails. And now I've been communicating with him on email about certain customer lifetime value type problems. And then also, don't be afraid to reach out to people you've met. I've met Raj over here, and we've had coffee a couple times. And don't be afraid to reach out and take advantage of people you know in the field. Ryan's been instrumental in helping me, and so just be willing to be out there. And then the other thing is return the favor. Go out and be a mentor to somebody, because I feel like the valuable part of being a mentor is that it makes you think of things differently than what you think about them. Because in my mind, I think I've got everything solved, but I can't explain it to somebody. And once I explain it to somebody and they look at me with that look like, I don't know what you're talking about, I realize maybe I don't really know what I'm talking about. If I can break this down a little more simpler, help you understand it, I actually learn how to explain it a little bit more and know it a little bit better than I did before.
So thanks, Jason. And that was kind of a whirlwind tour here of our perspective on how to get a data science job. And if you can pull up, Jason, that last slide that has our contact info, and it also has where you can go to get links to all the advice that we've shared. Yes, slide 14. Because in addition to sharing our own experiences, we try to curate some of the best advice that's online, right? Because it can be overwhelming. And people who are trying to sound smart can tell you, like, you need to read the whole Elements of Statistical Learning cover to cover, and you need to read the new deep learning textbook that just came out cover to cover. And it's like, you know what, to be the best, you absolutely do. But to get your first job in data science, you absolutely do not. Learn the basics, hustle, be a warm candidate who can show and tell through a work sample like a Jupyter Notebook that you can do the job, and you'll get that first data science job, and you'll go from there. So I encourage you to reach out. We are hiring right now a data scientist on our team at Country Financial. The worst thing that you could possibly do is go to our website and apply as a cold applicant. You know, if you are interested, then email myself or Jason. Check out some of these advice and the links. Some data scientists who are better than myself, and they can help you learn what it's like to break into this exciting field. Thanks.